Good morning, students. Welcome to another physical science class. In this online physical science class, I am going to continuing the last part of the revision of magnetism. So let's start. Now here I am going to discuss first some important thing about magnet. First one is degree of induced magnetism. The strength of induced current depends on the strength of the magnetic field. The velocity at which the coil or the magnet is being moved and the length of the conductor which is perpendicular to the direction of the motion, and finally the resistance of the conductor. So if you want to write point 5, then you have to follow your book. So point 5 is also I am telling you, induced magnetism depends on the nature of the magnetic substance. For example, greater amount of magnetism is induced in iron than in cobalt or nickel. Number 2, the distance between the magnet and magnetic substances. Shorter the distance, more the magnetism induced. Point number 3, the pole strength of the inducing magnet. Greater the pole strength of the inducing magnet, larger is the magnetism induced. Number 4, the nature of the medium in which the including magnet and magnetic substances are placed. If the intervening medium be glass or wood instead of air, less magnetism would be induced. Now the next very important question. Can poles, that means poles of magnets, be isolated? There is never an isolated pole or a monopole. All magnets attract iron, such as that in a refrigerated door. However, magnets may attract or repel other magnets. But the two poles of a magnet can't be isolated. See the diagram? In the diagram, it has been clearly shown. First one is a bar magnet. If we will be able to divide it, again it will form another piece of magnet. That means again two poles will be formed in that particular cutting portion. So you can say that if we try to separate two poles of a bar magnet by breaking it from the middle, we shall get two complete magnets, each having two poles and each poles of same strength as the original one. So each part would behave as a complete magnet. If the pieces are broken to 4 pieces, we shall see each piece is a complete magnet having two poles whose pole strength is same as the original one. In this way, if we break the magnet in whatever small pieces, each piece would be a complete magnet of the pole strength equal to that of the original one. So isolated single pole is not possible. Magnets are always dipole. Now, what is the molecular theory of magnetism? Molecular theory of magnetism describes every magnetic substance as being a collection of dipoles that are initially in a state where there is no specific and uniform orientation as a result of the application of a magnetic field, and because of this, the net magnetic field strength of the substance becomes zero. Okay, now I am explaining this, whatever I am saying. First you see the diagram. There is a bar being magnetized, means a bar magnet being magnetized. Okay, so bar magnet means it's a steel bar. Suppose it's a steel bar or iron bar. Now the second one is a magnet. So when you are dragging that magnet on the upper surface of that particular iron bar or steel bar, whatever it is, iron bar, quite possible, iron, cobalt, nickel. because they are all magnetic substances. So what actually happened in small yellow color, small pieces of magnets are called Weber element. Okay. So from the fact that an isolated pole is not possible, Weber, a scientist, suggested that each molecule of a substance is a complete magnet having two poles of equal strength and opposite type. These molecular magnets are named after the name of Weber as Weber element. So these yellow colored small magnets are Weber elements. Afterwards, based on Weber's theory, Ewing, another scientist, put forward the molecular theory of magnetism. So according to Weber, under ordinary condition, molecular magnets of a magnetic substance remain arranged randomly. And so, the effect of any molecular magnet is neutralized by other molecular magnets. And as a result, there cannot be any free pole on the surface of magnetic substance. See, they are already in random motion. These Weber elements are already in random motion. You see, in the diagram, they are in scattered condition. But when you are dragging a magnet on the upper surface of this iron bar, they are slowly arranged. That means they are all magnets, and see, they are facing the opposite pole each other. They are arranging themselves. That's why there is no magnetic strength at the middle of one magnet also. So you can say that although each molecule is a complete magnet, there is no external net effect of them because they are neutralize each other. Hope so you have understood this. When the magnetic substance is magnetized by applying magnetizing field, the molecular magnets are arranged parallel to the direction of magnetic field. Under this condition, opposite poles of the molecules come face to face and hence neutralize effects of each other. Only effects of molecules at the two ends remain effective. So one end becomes north pole and other ends become south pole. So it is evident that at the two ends there would be two opposite types of poles and they are of equal strength. From the diagram you can see that. Now, how does induced magnetism works according to this theory? When a piece of unmagnetized magnetic material touches or is brought nearer to the pole of a permanent magnet, it becomes a magnet itself. The magnetism is induced. A north pole induces a north pole in the far end. So magnetic induction can be explained on the basis of molecular theory. How? Let the pole, say north pole, of a strong magnet be brought near a bar of magnetic substance. Closed chain arrangements of the molecules would open up and south poles of Weber elements would be arranged, being attracted by the north pole of the inducing magnet, while the north poles being repelled would be arranged in the opposite direction. As a result, in the end of the bar near to the north pole of the inducing magnet, there would develop a south pole and at the far end a north pole. Now, last topic of this chapter, that is terrestrial magnetism. Terrestrial magnetism means the magnetic properties of the earth as a whole. What causes Earth's magnetism? The magnetic field of Earth is caused by currents of electricity that flow in the molten core. These currents are hundreds of miles wide and flow at thousands of miles per hour as the Earth rotates. The powerful magnetic field passes out through the core of the Earth, passes through the crust, and enters the space. See the first diagram, terrestrial magnetism, the most natural source of magnetic field is Earth. So there is always a magnetic field present everywhere near the Earth's surface. The magnitude and direction of this field can be obtained approximately by assuming that the Earth has a magnetic dipole moment about 8 into 10 to the power 22 joule per time located at its center. This dipole moment measurement is not in your syllabus, so you can ignore just this portion. Dipole moment about 8 into 10 to the power 22 joule per T. Rest of the portion in your syllabus. Now see the second diagram. Earth, within Earth there is a magnet. Magnetic pole, one side is north, another side is south. Okay. Now so we can say that it is seen that freely suspended bar magnet sets itself in the north-south direction. Always you have seen. An iron rod left for long along north-south direction is feebly magnetized with its end facing north direction, becoming a north pole and other end a south pole. From this phenomena, it can be concluded that the earth itself is a huge magnet. This idea was passed due to Sir William Gilbert. Earth's magnetic field is extended up to about 1 lakh kilometers above the Earth's surface. Of course, it is still not known exactly about the source of this magnetic field inside the Earth. If a huge bar magnet of length much less than the Earth's diameter be imagined, then we can explain the behavior of Earth's magnetic field approximately. South pole of the imaginary magnet lies towards Earth's magnetic north pole and its axis is along Earth's magnetic axis. So that means you can conclude that Earth itself is a huge magnet. And from this only terrestrial magnetism, this concept is coming. Thank you students. For any doubts or queries, please email me at shudeshnavan.sma@outlook.com.